Hello, my name is Andrea Michienzi from the University of Pisa, Italy, and together with Manios Krasanakis from CERTH, Thessaloniki, Greece, I will present the video tutorial of the contextual Lego network. As soon as users will start using our platform, they will create social relationship among them. Here on the right you can see an example. We call the graph induced by their social relationships the social overlay. In Helios, the social overlay has two key characteristics. Nodes and edges have an heterogeneous nature, and the relationships are contextual. The heterogeneous social network graph can be easily represented with a multi-layer graph, where nodes models the actors, edges models the relationships among those actors, and layers models the contexts. The heterogeneous social network graph is a very important structure, but we cannot expect that all nodes are going to store the whole structure for two reasons. First of all, Helios is a privacy by design platform, and storing an entire copy of the heterogeneous social network graph would break this principle. Moreover, it is also unfeasible for a node to keep a constantly updated vision of the whole social overlay, especially if the node is hosted on a low-end device, such as a smartphone. That's why we introduced the concept of ego network. The ego network is a social network model centered on a specific user called ego, here represented with a red node, and contains the ego itself, the alters, which are the nodes, the blue nodes here, which are the nodes directly connected with the ego, and all the social relationships, the edges. In particular, each node can maintain a portion of the whole social overlay that corresponds to its ego network, such that the privacy of users is not violated, and each node can maintain only the relevant information for its user. This is how we define the contextual ego network, the local view of a node, the ego, of the heterogeneous social network graph. It has all the key features we need. It is heterogeneous. Indeed, nodes and edges model different kinds of users and different kinds of relationships. Contextuality, because the relationships are organized in context. Dynamic, indeed the structure can change over time, both in terms of nodes and in terms of edges. And finally, it is local, because it is built around the ego. This is the structure implemented by the contextual ego network manager in Helios. As we see in this figure, the contextual ego network module is in the Helios core because it is the pulsating heart of the sociality of users. Indeed, it is used by many other core and extension modules. While the Helios platform is Android first, it is worth noticing that the module is implemented in plain Java, so it can be also used in other scenarios. I will now show a very basic example of its usage. First of all, to create an instance of the contextual ego network, one should call the method create_load, specifying the path where the contextual ego network will be stored and the ID of the ego node. The ego node can be retrieved by the method getEgo, called on the object contextual ego network, but other nodes can be created with the method getOrCreateNode, specifying the ID of the node, and if needed, also some additional data can be added to the node. On the contextual ego network object, one can also, through the object, one can also create new context using the method getOrCreateContext and specifying an ID for the context. Edges can be added to the context by the method getOrCreateEdge and specifying the source node and the destination node of the edge. On the edges, one can also add detected interactions using the method addDetectedInteractions, and as argument of the method, one can also attach some additional information concerning the interaction. Lastly, you can save serialize the whole structure using the method save on the contextual ego network object, such that the next call of create_load will read it from memory instead of creating new. I will now leave the podium to Manios.
Hello from me too. I'm Manios from CERTH, and I'll touch on more advanced concepts of the contextual Lego network module. First of all, it is possible to listen to events occurring in the contextual ego network and trigger callbacks, such as when creating nodes, context edges or interactions, or when adding nodes to context and so on. The example code demonstrates the process of constructing and adding objects of this listener class to an ego network. This is achieved through the latter's addListener method. This particular listener implements a custom callback when object creation triggers occur. Then it simply prints a message when a new node is created. Moving on, it is possible to dynamically attach your own data to context nodes and edges. These three classes provide a getOrCreate method that creates or retrieves attached data objects. In the example code, this method is used to attach an instance of a class called data to a node. This instance is then returned and its toString method is called. Only one object is instantiated for each class and each component, and subsequent calls to the getOrCreate method will just return the already attached object. Attached objects are serialized alongside their respective components, therefore they persist after saving and loading the ego network. To define a class that can be attached to a component, it suffices to provide an empty default public constructor. Declaring this constructor is mandatory, as it is also used for deserialization when loading the ego network. Optionally, you can also declare a constructor that takes the component as an argument. This will be preferred for creating an object instance. For example, this code defines a data class that needs to be attached to a node. It throws an exception otherwise. This class remembers the node it is attached on, and its toString method describes this relation. We next address the concept of dynamic context management. Basically, the contextual ego network allows us to remove context contents from memory, so as to reduce consumption. To do this, it suffices to call the cleanup method of context. This method first serializes the context and stores it in a file. It then sets its edges and interactions to null so that Java's garbage collector can remove them from memory. This will be automatically reloaded when needed, for example when the addNode or getEdges methods are called. It is important to stress that these module's operations are organized so that unloading and subsequently automatically loading context should not affect at all how code depending on our module is developed. A final feature provided by the contextual ego network module is a fail-safe recovery mechanism. This aims to prevent catastrophic data losses that occur when applications crash, but the save method of the ego network has not been called yet. Adding this mechanism to the contextual ego network is as simple as adding a listener to it. That listener first recovers data from previous log files, saves the ego network, and clears those logs. It then starts loading new events. Future directions of improving the contextual ego network module include integration with the storage module of the HELIOS core and dynamic unloading for objects that are attached to components, similarly to the context cleanup method. This module is already being used by other modules and tabs of the HELIOS ecosystem. In particular, it is integrated into the context and trust managers of the HELIOS core, as well as the content-aware profiling and social graph mining extension modules. Furthermore, it is used by the content-aware profiling demo app, HELIOS Talk, and the test client. The contextual ego network module source code is publicly available in this GitHub project. There you can find the full Java doc, as well as instructions for Gradle and Maven integration through Jetpack.